Hello friends, this is Mike from Wright, and this is the explanations video for SAT 2's Math No Calculator section, question number 10. This is a nonlinear equation graphs question. So the question doesn't exactly say this, but they're asking, for which equation is y always greater than -1? The specific phrasing is, which of the following equations has a graph in the xy plane for which y is always greater than or equal to -1? Now, questions like this that have an English language prompt that describes a graph, just like question 9, one question ago, when they give you a question where they're explaining, like asking you to imagine a graph, usually the best way to solve those questions is in the language of graphs, is to either imagine or to physically draw graphs that go with each of the equations. So here they've given us 4 equations, and I've split up these answer choices, right? The equation for answer choice A is y equals the absolute value of x minus 2. B is y equals x squared minus 2. C is y equals x minus 2 squared, so that's kind of similar. And D is y equals x cubed minus 2. And they're asking us which of these equations is such that it's always, the y coordinate of the equation is always greater than -1. It's always greater than -1. Now, in terms of what they're asking on a graph, what they're saying is on an xy axis, the y variable needs to always be higher than -1, right? If you have a y coordinate that's lower than -1, that's going to be a wrong answer choice. So we're looking for graphs that always stay higher than -1. So that's what we're looking for. In which equation is y always greater than 1? So the way to solve this question is to know the basic equation forms, to know the basic way each of these equations look, and then to know how they're being transformed by the changes that are being made to them. So I'll give you, well, each of these is going to be an example of what I'm talking about. But the sort of nuts and bolts of what I'm talking about here is in the topic videos for graphing linear equations and for nonlinear equation graph. Those topic videos are going to be what covers it. All right, so let's look at answer choice A first. Answer choice A says y equals the absolute value of x minus 2. And here I just want to show you, in this particular example, how this equation works. The core, like sort of bare bones of this equation is that it's an absolute value type equation, and those look like a v. Here in all of these answer choices, I've given you a dotted line version of the equation, which is like the default version. And then I've given you the solid line version, which is the version that's the actual equation. Here in answer choice A, the dotted line version is this is just a graph of y equals the absolute value of x, and it looks like a v with its center in the origin. And we could think about why that is. I mean, the absolute value of something is you take that thing, and if it's a negative version, you just change it to the positive version of that thing. Otherwise, it's the same. So this is just the graph of y equals x, right? Except every single time x is negative, we're saying, no, like I don't like negative numbers. Be a positive version of yourself. So here, this is the graph of y equals x on this side, right? So when x is 1, y is 1. So x is 1, the absolute value of 1 is 1, so y is 1. So here x is 1, y is 1, x is 2, y is 2, x is 3, y is 3, etc. Because the absolute value of positive numbers is just themselves, right? Y equals the absolute value of x, that's just, y equals the absolute value of 3, that's just 3. So you got the point 3, 3, 4, 4, 5, 5, etc. It just goes up in a straight line. Now, instead of going down totally into a straight line, though, the moment it goes to cross the y-axis, it bounces up again, because if you're trying to tell it that that the absolute value, that x is a negative number, it'll be like, no, be the positive version. So the absolute value of -1, for example, is just 1. So this is pretty promising because we don't like negative numbers here. We want our whole graph to be below -1. And here the default graph is just like, if x is -1, then the absolute value of -1 will be 1. So the y will bump back up to 1. Same thing with -2, x being -2, y will be like, no, I don't want you to be the negative version, I want you to be the positive version, so if you hand me a -2, I'll give you a positive 2. That's why this absolute value graph looks like this v. Now, what this -2 at the very end is doing is saying, all right, do all that stuff, right? Take care of this absolute value stuff, do all those calculations, and then at the end of all of that, subtract 2 from whatever your answer is. So the effect that this has is to take that v and move everything down by 2, right? So you can see that at the origin, right? The absolute value of 0 is 0. And so that was this point. But then we took that point and we subtracted 2 from it. Right? So here this 0, 0 becomes 0, negative 2. But then otherwise it looks the same, right? The absolute value of 1 is still 1, but then it goes down by 2, right? You find the absolute value of 1, that's 1. And what used to be just the point 1, comma 1 is now the point like 1, comma 1 minus 2. So it drops down 2, and that becomes the point, what is, I guess the point 1, comma negative 1. That's it. So generally speaking, that's all just to say, absolute value graph looks like this. This negative 2 drops it down by 2. Now in terms of our actual question, we want to know, is this graph, is the y in this graph always greater than negative 1? So here I've drawn a line, this dotted orange line, and just for reference, this is in all of the answer choices. And this line is the y equals negative 1 line. This is the line at which y is negative 1. Here, this is the point 5, negative 1, and here's negative a million, negative 1, right? Y is negative 1 across this whole thing. And I've just said that this is the death zone. Anything lower than negative 1 is the death zone. We want our right answer is going to have everything is always going to be greater than negative 1. So if anything is less than negative 1, it's wrong. Now, our graph took the absolute value graph and moved it down by 2. And in doing so, it took part of the graph into the death zone. The default graph would have been above the death zone because it takes everything positive, and that's nice. But here we dipped it down to, and this point, 0, negative 2, that's below the death zone because y is negative 2. And these points, all of these points that are crossed out, those are all points where the y values are less than negative 1. Now you can do that just, you don't have to know that default shape of the graph. You could also plug in a few sample points. I think that would be a good way, a good sort of backup plan as well. You could plug in the point 0, for example. Absolute value of 0 is 0. 0 minus 2 is negative 2. And now here you have a situation where y is negative 2. That itself proves this answer choice wrong. A couple ways of doing it. I think knowing the basic graph forms, though, is the best way, not least because it's that's a skill that you need to know anyway for the SAT. All right, on to answer choice B. Answer choice B is the equation y equals x squared minus 2. And we're going to explain this in the same way in terms of the basic shape of the equation, the type of equation that it is, and then how it's being transformed by the way it's different from that basic shape. So this is a parabola. It's a y equals x squared kind of equation. And so I've drawn, dotted, the basic shape. Y equals x squared. It's a parabola with its vertex at the origin, at the point 0, 0, y, because 0 squared is 0, right? 0 times 0 is 0. So here's the point. X is 0 and y is 0. And then it goes the point 1, 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. So it sort of goes up and up and up, right? It's a parabola. OK, what this negative 2 does to the parabola is it takes, kind of like in this one, and spoiler alert, this is the same thing that's going to be happening in D. This negative 2 says, do all your stuff. Do the x squared stuff, do all your stuff, and then at the end of all of that, take that and subtract 2, and that's going to be our new graph. The net effect that it has is going to take that parabola and move it down 2, just like answer choice A. Right. So instead of having this dotted line graph here, we're just going to take that whole parabola, bump it down 2, so that instead of having its vertex at the origin, it's going to have its vertex 2 lower than that at the point 0, comma, negative 2. Now, just like in answer choice A and in all of these questions, we want our y to always be greater than negative 1. We want the graph to always be higher than this line, the line y equals negative 1 here. So this is, I described this as the death zone. The death zone is if there's anything in the equation in this zone, then the answer choice is wrong because we need everything to be above y equals 1. And in this graph, all of this stuff that I've crossed out, this is all in the death zone. The vertex is in the death zone, and everything between here and this negative 1 is in the death zone. Now, again, you can get to this answer by knowing that a parabola by default looks like this with its point at the origin. And that's pretty good, but then knowing that what this -2 is doing, the effect that it has on how the graph looks, is to move it down by 2. Right? Then you want to graph, or at least imagine a graph that looks like that, where it's like a parabola, but it's down by 2, and ask, is it ever going to be lower than that y minus 1 line? And the answer here is yes, because it dips down by 2, which is like, it's substantially lower than the y equals -1. Started at 0, dipped down by 2, it gets 1 lower than y equals -1. OK. I'm going to go to answer choice D now, because there's similarities, structural similarities between A and B and D. And here, answer choice D, sort of same thing. It's another type of nonlinear equation to graph. It has a different fundamental shape. But the -2 in this equation is going to do the same damn thing as this -2 did and as this -2 did. The net impact it's going to have is to be like, do your stuff, take care of your business, you do you, and when you're done with all that, come to me, I will subtract 2 from you, and we will move the graph down by 2. That's what's going to happen here. So here, this is the graph of y equals x cubed, and you could just know, and maybe you do just know, that the basic shape of the graph looks like this. It's kind of a squiggly wiggly like this. The reason why it looks like this instead of being like upright like a parabola is that cubed doesn't care about negative numbers. Or rather, if you try to cube a negative number, like whereas if you're trying to square a negative number, it's like -1 times -1, 2 negatives is a positive, so it turns positive. Here, if you're cubing a negative number, it's like -1 times -1, so that's a positive, and then you need to do it a third time, so it turns negative again. That's why there's negative components to these odd, and these are called odd functions with an odd number in their exponent. They don't turn everything positive like these ones do. So, all that's kind of just commentary, though. And really, the basic equation of a y equals x cubed type graph is like this. It's like this squiggly boy right here. Now, what this -2 is doing, as I mentioned, is it's just saying, hey, cube the thing and then bump it down by 2. So that's where this comes from, right here. But this part was kind of unnecessary because the basic shape of the function involves a ton of negative numbers. Look at all these negative numbers all here. All of this stuff, all of this is in the death zone. Right? Here's the y equals -1 line. Here's the death zone. Anything below it means the answer choice is wrong. And a y equals x cubed graph just is the worst. There's so much stuff, literally infinite stuff below the death line. So this is like the wrongest of all the wrong answer choices. OK. On to our right answer, answer choice C. Here, the -2 is inside parentheses, and that is what's going to make all the difference. I'm going to sort of show you briefly how it works. But again, this is like answer choice B in the sense that the thing that it is an x squared graph. It's a parabola graph. The basic shape is the same basic shape as answer choice B. It's just a parabola with its vertex at the origin. But this -2, instead of being like, oh, like take care of all your stuff and I'm going to come in at the end and just lower everything by 2, comes in much earlier in the process. In fact, it comes in before we've decided to square stuff. So the impact that it's going to have is different than if we told it to wait until the end and then subtract 2 from everything. It's different, for example, than it would be if we could just have literally this graph and then say -2, and this -2 would bump everything down by 2. This -2, though, is going to move everything to the right by 2. We can sort of show you intuitively maybe how that works. We could just use a couple sample points, right? Let's just use the point 0. 0 is going to be a good one. Well, in the normal graph, y equals x squared, the 0 squared is going to be 0, right? 0 times 0 is 0. So at the point 0, x squared is 0, so y is going to be 0, so the point 0, 0. When you have this graph, however, this equation, however, the thing you're squaring isn't going to be 0 anymore. Here, 0 minus 2 is -2. Right? 0 minus 2 is -2. And then we're going to square -2 and get 4. So what this -2 is doing at the point 0 is bumping it up a whole lot and making this point 4. Now the question is like, where is y going to equal 0? And we can just think about what happens, like how we can make this whole thing 0. And the answer is to take x and make it 2. The reason why is, well, 2 minus 2 would be 0, and then we would be squaring 0, and that's how we would get 0. Here, when x is 2, then you subtract 2 from it and square it. So you subtract 2 from it, you get 0, you square that, it turns into a 0. Which is all just to say, when x is 2, y is 0. The place where where the parabola crosses this y-axis is 2 to the right than it used to be. Because instead of changing the thing at the very end, this -2 has an impact on the thing we're squaring in the first place. It's not saying, square the thing, come back to me, I'll subtract 2. It's like, no, tell me what you're going to square. I'm going to subtract 2 from that thing, and then we're going to square it. And that's going to be all the difference. OK, so those are just a couple sample points. And here, just again, this graph moves over a couple. And because of that, it didn't move down at all. So the death zone, right, y equals -1, and everything below it, there's nothing in this graph that falls below the death zone, because this parabola, instead of being moved down, has been moved to the right. All right, that's it for this question. I'll see you all in the next one.